All right, now we're recording. All right, so then we're going to list the 6 strong acids. Does anyone have any ideas what some of them are?
Hydrochloric acid.
Yep, that's one of them. 5 more. How about hydroiodic acid? Hydrobromide acid, HBr.
HNO3.
Yeah, that's, I think that's considered nitric acid. I guess I could do that. There we go. There we go. Now I can block the key from y'all. Dang. Now I lost the key. There we go. Okay. All right, so we have hydrochloric, hydrobromic, hydroiodic, then nitric acid, which is this HNO3. And remember, the way to think of that is, or I'll just do it here. It's H bonded to an NO3 ion. It's not hydrogen bonded to nitrogen bonded to 3 oxygens. It's hydrogen bonded to a nitrate ion, which is a nitrogen bonded to 3 oxygens. And then we have, what else do we have? The other 2, they're more like that, so I'll just give them to you. They are sulfuric acid, which is going to be H2SO4, and think of that in the same way. That's 2 hydrogens bonded to 1 sulfate ion. And then the last one is HClO4, which is chloric acid, I believe. I would have to look that up to find out the exact name, but HClO4. And those are your 6 strong acids. So if you see those, you know it's going to dissociate completely, and you don't have to do all of the stuff we've been doing. So usually these aren't really asked about because they just make every problem easier, and Dr. Schultz does not like making things easier. All right, so now we have 6 strong bases. There's more than that. I think there was 7 or 8. But what are the 6 strong bases that you can think of?
KOH.
KOH. That's one of them. That's potassium hydroxide. Yeah. What's the other OH that you can think of? One that we talk about all the time.
Calcium?
No, it's sodium. Na. NaOH. That's the bleach. I can't remember what exactly it is, but it's the one that's talked about the most, sodium hydroxide. And then there's another one. It's called lithium hydroxide. And then we get into the more difficult ones. There is calcium hydroxide. You were right, actually. My bad. OH, is it 2 OHs? Yeah. OH2. That's right. Then what else we got? Magnesium and beryllium hydroxide. So all your strong bases are going to have hydroxide in them. So the important part is to remember what goes in front of the hydroxide. So the magnesium, the calcium, the lithium, sodium, and potassium. And what was the other one? Beryllium. Yeah, beryllium hydroxide. If she's going to give you a strong base, it's usually going to be one of these 3, though, because these are more difficult to remember, and she does like these a bit better. So it'll usually be these that she gives you, but don't be surprised if she does throw one of these in there. All right, then we have the pH scale. So that's 1 to 14, right? What is considered neutral?
7.
7 is neutral, and that's, water. And then which one's acid? Is it 1 to 7 or 7 to 14?
1 to 7.
1 to 7 is an acid, and then that means that 7 to 14 is a base. Still neutral, right? All right, and then now we're getting to the more hard stuff. I'll go ahead and move this down to the next page. So describe Kw and the relationships between hydrogen plus ions and OH negative ions in acids and bases. So
Is Kw the equilibrium water constant?
what was that?
The equilibrium water constant?
Yeah. What do you remember the value that it is?
10 to the 14th power?
Yeah, it's 1.0 times 10, and then it's negative 14 or positive 14. I can't remember. It is negative 14. So to the negative 14th power. And that's a constant. That's the way it'll always be. That's something you got to remember. Kw is equal to 1 times 10 to the power of negative 14. All right, what else do we have from that? Oh, and then Kw is also equal to your concentration of hydrogen, right? Times your concentration of hydroxide. There we go. What else with this? Okay, so for an acid, when you have an acid, your H plus ion is going to be considered to be greater than your OH. Concentration. And same way with a base, your OH concentration is considered to be greater than your hydrogen concentration. Go ahead and do that. Or I'll just, yeah, like that. And then when you're neutral, when you're at 7 pH, she might throw in a trick question like that too. Like you're at a neutral pH, which is greater, your hydrogen ion concentration or your hydroxide ion concentration? They're both equal. So at neutral, both of these, and they are set to be equal to each other. And I believe, yeah, since they're equal to each other, but they still have to multiply to get that, they both equal 1.0 times 10 to the negative 7th. There we go. And that's kind of all you need to know for this specific question. What kind of reaction will form a salt?
An acid-base reaction?
I think that, yeah, that was a little more simple than I thought it was going to be of a question. But yeah, an acid-base reaction forms a salt. What else does it form, though?
Water?
Yeah, it forms water and a salt. Forms water and a salt. That'll be every time. And you can think of that as if you have HCl, right, plus NaOH, then you're going to get, and this is going to dissolve completely, remember? Then you're going to get this hydrogen right here is going to combine with this hydroxide to make a water. So that's going to make H2O. You have 2 hydrogens and 1 oxygen. Plus, then you have sodium and chlorine. So it gives you sodium chloride, which is table salt. And that reaction works with any of the strong acids and strong bases. I guess that's one way to put it. Strong acid and a strong base. Actually, no, I'm not going to say that because weak acids and weak bases also form salts. So I'll leave that guy. How do you find the pH of a strong acid? Is that asking?
Isn't that the Ka equals the A and H over HA?
I think that's one way to find it, but the way it's saying on the key is to do the basic equation, which is just the pH equals the negative log of the H plus ion. There we go. But I'm pretty sure the way you described it was right too. What was it? KW is equal to, what was it?
Isn't it A and H over HA?
Wait, what was the numerator again? ANH?
Yeah, A and H,
Oh,
and
like,
then
okay.
HA at the bottom, and the denominator.
I think, oh, that's asking about a different part. That's when you have a weak acid.
Oh, okay.
Yeah. pH of a strong base. Just look at that. It's pH is equal to negative log of the hydroxide ion concentration. There we go. And then why is salt considered a strong electrolyte?
Because it completely disassociates.
Yep. It completely ionizes and disassociates. Salt will completely ionize / disassociate in water. Find the pH of a 0.0045 molar solution of HNO3. I think you just use this right here to solve that. So if one of y'all could solve it real quick. I don't have my calculator with me right now. I'll set it up. It's pH is equal to negative log of 0.0045, which is equal to, anyone got it? .35. And then, and remember it's pH, so it doesn't have, actually that is not right either, because remember whenever you are, that's sig figs. Whenever you're finding the pH, you count the number of sig figs. Oh no, that is right, my bad. The number of sig figs is equal to the number of decimals. So 2 sig figs, and then we go 2 decimals for it, so 2.35. And then find the pH of 0.0025 molar solution of lithium hydroxide. Same exact equation. pH is equal to negative log of 0.0025, which is equal to 11.40. There we go. And that is, you can check that because this is below 7 and it's an acid. It's a strong acid. And then this is a weak acid and it's above 7. So there you go. That's one way to check. Find the hydrogen ion concentration of an acid with a pH of 2.34. Does anyone remember the equation to get the concentration from the pH?
Isn't it 10, but with the power of pH?
10 to the power of pH. So it'd be 10 to the power of 2.34, right? Let me check the review. 10 to the power, oh, you almost got it right. There's one little part you missed.
No, negative.
Negative pH, there we go. 10 to the power of the negative pH. Ooh. How do I do that right? Ooh. I hate exponents on the computer. 10 to the power of negative 2.34. There we go. I'm gonna make everything a little bit bigger too. There we go. Okay, 10 to the negative 2.34, which is then equal to, oh, it's then equal to 4.6 times 10 to the negative 3 molar. All right, and then so same equation here, 10 to the power of negative pH, right? 5. And that is equal to, preview, hydrogen ion concentration. Oh, wait, no, I messed up there myself. Because remember, whenever, God, what did I do? There we go. Okay. Remember, if you have an acid right here, then you're solving for pH, or you're using pH. But this is the pH. You need to use the pOH. So what we do is, okay, yeah. So we need to take the pH. So before we do this right here, we need to take the pH and find the pOH. So the pOH is equal to the pH, or the 14 minus the pH. So we do that. It's equal to 1.65. And then we plug that number, the pOH, into here. Erase that, 1.65. And then we get 0.022 molar. 0.022 molar. There we go. Why is this font so terrible? Times New Roman. There we go. Makes it a bit easier to read. What combinations will give you acidic, basic, and neutral salts? So this is asking like a weak acid plus a weak base will give you what? Weak acid, weak, and strong base. So what will give you an acidic salt?
Strong acid and weak base.
Yeah. And remember, that's not because of the strong acid, that's because of the weak base, right? It's weird to think about it like that, but the easiest way to think about it is just strong acid results in more acid, so it's acidic. And then a base is what? The opposite, so weak acid. And a strong base, why is that wrong? Oh, and this is a acidic salt. Base. A basic salt. And then, so what gives you a neutral salt?
Isn't that strong acid, strong base?
Yeah, that's strong acid, strong base. And then what would a weak acid and a weak base give you?
Wouldn't that also be neutral?
No, this is the trick question, remember, because it can be either acidic, basic, or neutral.
Oh, okay.
We have to solve for these. This is the ones we solve. One, it's a weak acid, so I'll just put question marks here. Weak acid plus a weak base, you have to solve for it. Move this on down. So what is a buffer solution? Do y'all remember the definition of a buffer solution?
No.
All right, so a buffer solution is when you mix, let me look up the actual definition. It's a solution which resists changes in pH upon the addition of small amounts of strong acid or strong base. So it is a weak acid, I'll just go ahead and type it, weak acid or a weak base mixed with its conjugate base, or conjugate, I'll just put conjugate, and it resists changes to the pH. Because remember, whenever you have a titration, you're always titrating a buffer solution, and that's why it takes a while for it to change, and then it changes all at once. And that kind of goes into what an indicator is. What is an indicator?
It's an additional substance that indicates a change in pH.
Yeah, that's pretty much exactly it. The one y'all use is that phenolphthalein. I don't know how to spell that. I'm not going to even try. There it is. Phenolphthalein. And that's one of your indicators, but the definition for an indicator is, yeah, a substance you add to a buffer solution to identify the change in pH. There we go. And then, yeah, think of phenolphthalein. All right, delta G, delta H, and delta S. Again, I can't do the delta G's, so we're just gonna do those. So what are these?
G is Gibbs free energy.
Yeah. Free energy. Delta H.
Enthalpy.
Enthalpy, yes. And then what? That's wrong. What is this one then?
Entropy.
Entropy. So this is measuring the heat. This is measuring the disorder, and then you put them together plus the result, then you get Gibbs free energy. Given the 3 laws of thermodynamics, I don't think we've gotten to this part yet. Right? We haven't gotten to here yet in lecture.
I'm not too sure. We did finish up chapter 16 yesterday, so I don't remember exactly going over that. And
I don't remember that either.
Okay. That'll probably be Monday's lecture, is the 3 laws of thermodynamics.
Well,
we'll say,
Monday we're doing kind of like a class review.
oh, then this might be the next unit then. So just don't worry about that. Okay, and then we start getting into the practice problems. I think that's a good place to stop because we got 3.5 minutes left. So on Monday, we'll go back into this and just review all the practice problems. And it also has the equations list on the key that we'll go over. So this is what we'll do on Monday, is all these practice problems.
Alrighty, thank you so much.
Absolutely. Can everyone send me their student ID that hasn't already? And then once you do that, you're good to go. Oh, yeah, I got everyone. So y'all are good to go. Have a good day.
All right, yeah, you too.